Okay, so I'm going to be teaching the elimination method. It's a very simple one. You should be able to do this. Before I start though, I shortened the assignment. The assignment is only 1 through 5. 13, 14, and 21 is the shortened up assignment. Okay, the elimination method is 5x minus 3y equals 23, 2x plus y equals 7. Yesterday we learned the substitution method. Today we're learning the elimination method. What's the elimination method? Basically, you need to get the x's to look the same, opposites, or the y's to be opposites so you can cancel them out or eliminate them. For example, I'm going to take this second equation and I'm going to multiply everything by 3 inside of it. So I'm going to write the first one down. And the second one I multiplied by 3. So I'm going to change it to 6x plus 3y equals 21. I'm going to draw a line underneath it all. 100% it should be a plus. Why should it be a plus? Because the part that I'm eliminating should be opposites of each other. Again, make sure they're opposites of each other. And now I'm just going to add them up. 5x and 6x makes 11x. This part cancels out because they're opposites of each other. 44 is on the right hand side, so x equals 4. This is faster than the substitution method from yesterday. We're not done. Remember yesterday we wrote it as an ordered pair. We're going to do the same thing today. X is equal to 4. Now we have to find the y. All you do is you substitute inside of here or inside of here that x equals 4. So I'm going to do that. And I'm going to pick the easier one. I'm going to pick this one right here. And I'm going to substitute in place of x, 4. 2 times 4 plus y equals 7. 8 plus y equals 7. So y must equal a negative 1. Final answer. If I did it right, that answer should work into both of those two equations up above. Okay, the next template is just going to be a little bit harder. The reason why this is harder is because in the first problem, I only switched to one equation. In this problem, I need to switch both equations. So, let's just look at the two equations really quickly. I'm going to look at the a's first of all, and you have to go bigger than 2 and 3. And you have to think of a number that's bigger than 2 and 3. And most of you know that it's going to be a 6 and a negative 6. If I decide to get rid of my a's, I need to have a 6 and a negative 6. If I decide to get rid of my b's, I have to go bigger than that. And I need to come up with a number that's the same but are opposite. What's bigger for 8 and 5? You would have to go 40. So keep in mind you can either get rid of the a's or the b's. And I'm just going to work with the a's. So in order to work with the a's, I'm going to multiply this one by 3. And I'm going to have to multiply this one by negative 2. And why am I multiplying by negative 2? So that my a's are going to be opposite. So here I go. You got to be careful. You got to go slow. You can easily make a mistake on this. 2a times 3 is 6a plus 24b minus, not minus, equals negative 24. Okay, now I'm going to multiply the second one by negative 2. Negative 6a positive 10b equals a negative 44. I draw my line 100%. I should be adding. And yes, these two definitely are opposite of each other. If they're opposites, they cancel each other out. So I have 24b plus 10b equals 34b equals a negative 68. Divide both sides by 34. B equals a negative 2. Again, I am not done with this problem. I need to go up and write my ordered pair. In the last problem, we used x's and y's. In this problem, we're doing a's and b's. Make sure you put them in alphabetical order in the ordered pair. B is a negative 2, It goes here because it kind of stands for the y. And now we need to find the a. You can go up into this equation. You can go up into this equation. You could even go up into this equation, or you could go up into this equation to find the a. I'm just going to go up into the first one, so I'm going to bring it over here. 2a, in place of my b right here, I'm going to substitute a negative 2 in there, and that's how I got the negative 16, and that equals a negative 8. So 2a equals, I add 16 to both sides, that makes 8. So a must equal 4. Final answer. Okay, the last problem. Before we go into the last problem, I need you guys to just add a little star to this. Sometimes both variables eliminate. And you'll see this also on the ACT. What happens when both variables eliminate? What do I mean by that? I mean, do you notice up in this problem the A's canceled out and I still have B's, correct? But what happens if both variables cancel? You could have a false statement. You could have a true statement. Okay, what do I mean by that? So here's my false statement. So let's just pretend that the A's up here canceled out and the B's would cancel out. If you think about that, wouldn't you have a 0 then on the left-hand side because both the A's and the B's canceled out? But let's say we still have the negative 68 on the right-hand side. So we have no more variables left in the problem, and I'm talking about this because you're going to see this in today's homework. When the A's and the B's cancel out, you're going to have a 0 on the left-hand side equals a negative 68. Well, that doesn't even, that's a false statement. 0 can never equal a negative 68. There's going to be a no solution. No matter what you try, you're not going to be able to solve for the problem. It's a no solution. Okay? What does a true statement mean? Pretty much, kind of already know what I'm going to do. What happens when both variables eliminate? You still have a 0 on the left-hand side, correct? Because both variables eliminated. But, obviously, the only number on the right-hand side for it to be a true statement would have to be another 0 on the right-hand side. And since they're both zeros, 0 equals 0, it's a true statement. You're going to have many solutions. So, when you're working on your problems today, you might end up with an actual answer to the problem, like this one up here, or you might have your variables cancel out and you might have a false or a true statement. So keep that in mind when you're doing your homework. If your variables cancel out, it's no big deal. Just look at this little grid right here and it'll tell you what kind of an answer you're going to get. Okay, the last problem of the day is a story problem, just kind of like how we ended yesterday's assignment. The price of admission to a carnival is $2 for students and $4 for adults. 700 tickets were sold and they made $1,770. How much of each tickets did you sell? So, back a long time ago, do you guys remember making the 6-box charts to do this? A long time ago, I think this was chapter 2, section 2 maybe. The good thing today is we don't need to do a box chart. Because now, in this chapter, we're working with 2 variables. So that'll make it way easier. So, here we go. A stands for adults, and S stands for students. And all we're going to do in the story problem is, I'm just going to go back to the first page, we need to come up with 2 equations with 2 unknowns in each equation. It's not that difficult to figure this out. So, go back to this problem. If there are 700 tickets sold, we're trying to figure out which one, how many adults and how many students. So all you do is put adults plus students must equal the total amount of tickets that were sold. The adults plus students tickets equal the total tickets of 700. Then we need to know the price of how much they sold. We know that they sold a total of 1,770. I guess we really don't need the dollar sign. We're not going to put A plus S down because then it looks like they sold adults tickets for $1 and students tickets for $1, and that's not the case. What they did is they sold adults tickets for 4A and they sold student tickets 2F. So this stands for how many tickets were sold. This stands for the price of the tickets. Again, don't we have two equations and two unknowns? Again, you can either get rid of the A's or the S's. And I'm just going to multiply the top by a -2 so that I get rid of my S's. Again, you can get rid of your A's or your S's. So, -2A, -2S, -1400, because I multiplied the whole top. I'm talking about this one right here by a -2. I'm going to rewrite the other one down exactly the way it is. Draw my line, 100% add. If I did it right, the S's cancel out, which they do. 4A take away 2A is a positive 2A equals 370. So A must equal 185, which stands for adults. If there are 185 tickets sold for adults, obviously, students, it's going to be 700 minus 185, which is 550. Okay, that's all for the notes. Most of you probably don't even have to watch me. You'll understand how to do this. If you forgot your book, all you have to do is I photocopied the page with the answers attached to it. So right underneath the problem, you're going to see the answer. And since some of these are evens, you can look at my answer key that I gave you. Have this due by Monday, just like the first hour class did. Thank you.